Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concepts of IUPAC naming system. IUPAC stands for International Union of Pure and Applied Chemistry, and that's quite a mouthful, so we use IUPAC for short. And basically what we're going to look at today are alkanes, and just in case you don't remember what alkanes are organic compounds that have only single bonds between the carbons. There's no double carbon-carbon bond or triple carbon-carbon bond. So what is a substituent? You will hear that word thrown around quite often when discussing nomenclature. It's anything attached to the main chain. So what are the rules? Well, first you're going to find the longest main chain. If there's a tie, choose the path that has the most functional groups. Okay, let's overemphasize that. That's the most functional groups. All right. And then when you're numbering, start with the end that is closest to a substituent. If you did it correctly, your sum of all the numerical prefixes should be the smallest possible sum. All right. Then let's see. You're going to put a number. Okay, so if you have an alkyl group as a substituent, meaning you have like a methane, but it's not a CH4, it's a CH3. That's called an alkyl group, right? So the compound methane is CH4. But if we take off one of those hydrogens and then bond it to a main chain, it becomes CH3 with a line like that. Okay? Same thing with any one of those alkanes. Right? What you're going to do is you're going to list them alphabetically from left to right, and you're going to give a numerical coefficient, meaning a number in front of, so let's say, the methyl group, and it's going to represent the carbon to which the main chain branches off to that substituent, the methyl group, the ethyl group, the propyl group. Oh, hearing sirens. Hope everybody's okay. All right, so what is the iso group? The iso group is anything that has this basic structure, this motif of a Y-looking shape. If you were to do the line angle, it would look something like this. Okay. Now this one has an extra carbon, but it's still an iso group because that Y is still right here. You see it? Just has an extra carbon coming off of it. And then the isobutyl group is attached to some main chain. All right. Now let's look at the sec group. What is sec butyl or sec whatever? Well, sec stands for secondary. And secondary basically means that we're going to have two carbons attached to our main carbon that's attached to the chain. So here's the secondary carbon, and within these R and R primes, these are designated for carbon chains, meaning the first element attached in this R, whatever this R prime is a carbon. Same thing with this R, it's a carbon. It can have 10 carbons, it can have 1 or 2. Actually, probably if it had 1, you'd just write that in there, but it's just used to represent different carbon chains. Okay, so there's 2 carbons, so that's a sec group. Depending on how many other carbons are attached, then you can have, sec butyl or things like of that nature. Then there's the tertiary group, T-butyl. All right, basically there's 3 carbons attached, 1, 2, 3, and technically I should have a double prime there. Sorry. That's the T-butyl, or in this case it would be butyl group. And if you have repeats of prefixes, let's say you have 2 methyl groups, it would be di. If you have 4 ethyls or or 4 bromines, it'd be tetrabromo. Okay, things like that. I guess I didn't write the halogen rule, so if you're, I'll go into that here in a little bit. But if your alkyl group is really complex, just use the rules that you were using for naming the main compound, steps 1 through 4, and name it. Like this one here has a main chain of 1, 2, 3, 4. Let me go ahead and write them so you can see which ones I'm talking about. 1, 2, 3, 4, 5. Okay, so the compound would be pentane, but this is a alkyl group, meaning it's a substituent attached to a main chain, so this would be a pentyl group. And it's got 2 methyl groups on the second carbon, so it'd be 2,2-dimethyl pentyl group. And it'd be attached to some other bigger main chain. Alright? And I guess the halogens, I forgot to address those guys, I should might as well. So the halogens, so let's say we have bromine, you drop the ending and you make it bromo. So it'd be like 2-bromo or something like that. Or if we have chlorine, it becomes chloro. So forth, iodo. All right, that's basically the concept of nomenclature. So practice, 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 and learn these rules. The more of these problems you do, the more second nature becomes. This is only the beginning of nomenclature. Once we start getting into double bonds and triple bonds, alkenes, alkynes, also alcohols have slightly varied priorities that we have to deal with in nomenclature. But for now, this is a good introduction. I hope I've cleared up any confusion you might have. Practice, practice, practice. Thank you and have a nice day.